Hello, this is section 3.5 for Calc Survey, and we're going to be talking about derivatives of periodic functions, and we're only going to focus on sine and cosine. So first, we used our calculator to kind of explore what's happening when these are interesting ones that we do in Calc AB. So this one, if you graph this and you approach 0 from the left and the right, you notice, oh, it's actually approaching 1. And then this one actually approaches 0. So we had a little fun in class. We'll do these in class where we graph these and explore and see what you're approaching. But for our purposes, when we do our sine, our derivative of our periodic functions, it always creates a loop. And when we're in class, I'm going to sketch the graphs for us and we'll look at the graphs. And back in chapter 2, you kind of discovered this already. We did a worksheet where, when you do the derivative, when we sketched the derivative of sine, it turned into cosine, and we went from there. So, but that's basically the derivatives. It's sine and then cosine, and then the derivative of cosine is negative sine, and the derivative of negative sine is negative cosine, and then it loops back around to sine. Okay, so I always sing this, students: sine, cos, minus sine, minus cos, sine, cos, minus sine, minus cos. That's what my calculus teacher taught me when I was in high school. So sine, cos, minus sine, minus cos, and then it always loops around. Okay? So derivative of sine is cosine. Cosine is negative sine, and so forth. All right, now you can also use the chain rule. And in this case, you'll notice that back in 3.3, we talked about most of the chain rule types of problems are going to have a nice parenthesis and it's being raised to a number. So it's pretty obvious to see what the inside function is. Can get a little complicated with the trig functions, but this is a really basic one where the outside's actually sine. So you'll do the derivative of the outside, which is the sine part of it, which turns into cosine. Notice the inside stays the same, but then times the derivative of the inside. And then we do the same thing over here. Cosine, the derivative of negative sine, where the inside stays the same, times the derivative of the inside. So you're using the chain rule, but it looks a little bit different. It's not as obvious what the inside is. Okay, so here we go. Let's do some derivatives. So when I see cosine, you can sing through that little jingle: sine, cos, minus sine. So it's whatever comes after cosine, which is minus sine, and that's your answer. Okay, here's a chain rule problem. So you're going to do the derivative of the sine part. That's the outside function. So it turns into cosine, where the inside stays the same, then times the derivative of the inside, and you're done. Now in this case, rewrite that square root as to the 1/2, and it's x to the 1/2. So this is another chain rule problem where we do the derivative of sine first, that's cosine, inside stays the same, times the derivative of the inside. And if you wanted to rewrite this by writing that x to the negative 1/2, obviously make it positive when you move to the denominator, that'd be fine. This is an acceptable answer too. Okay. All right, now here's where things can get a little tricky. And here's where we talked about this in the last video with 3.4. You have to choose the path that you want to go down. And it's not, the paths aren't, there's not just one way to do the problem, and you're not wrong if you go down a different path. It's just you want to pick the easier path to go down, obviously. But this is one where you can decide. You can either treat it like a chain rule problem. So remember, this is cosine squared. So I move that 2 up so you can really see how it's a chain rule problem. Or you could write it this way and choose to do the product rule. It's up to you. Both answers will work. The reason I like to do this is because I know down the road we're going to be setting these equal to 0. And if we do product rule, that creates 2 terms, then I'll probably have to factor something out of those 2 terms. It's more algebra work down the road. But if you are more comfortable or would rather do product rule, that's perfectly fine. Okay, I'm going to do chain rule. So now that I've got it written this way, it's a lot easier to see that I'm going to pull that 2 down in front. Inside stays the same, subtract 1 from the exponent, then multiply by the derivative of the inside. And here's sine, cos, minus sine. So there's that minus sign again. And then from there, I move that negative in front, and that's my answer. Okay. Now, here's one where you have to, there's only one path to do this problem. You're going to be doing the product rule. So first times derivative of the second plus second times derivative of the first. And then if you left it this way, that's great. I went ahead and factored an x out of both terms. Either of these two answers are perfectly fine. Here's another, this one's a product rule, but then you have to do the chain rule as well. So you'll do first, and when you do the derivative of the second part, sine turns into cosine. Notice the inside stays the same, but I have to multiply by the derivative of the inside. That's where that 2 is coming from. Plus second, so sine of 2t, times the derivative of the first. Well, derivative of t is just 1. Okay. All right, and then here's another double chain rule problem. So I rewrote it, cosine of 2x all raised to the 1/2. So I took care, I start from the most outside and work your way in. So I pulled the 1/2 down in front, subtracted 1. Notice all the inside stays the same. Then I focus on this derivative. So cosine turns into negative sine, where the inside of the angle stays the same. But then I have to multiply by that 2, because that's the derivative. So double chain rule there. And then you just go into cleanup mode. But even if you left it this way, that'd be fine too. Remember, the only time I get picky is if you've got variables or functions that can be reduced when you have a fraction. All right, so here's a really good application problem, and there's one like this in your homework that you're going to want to make sure that you do. So plants do not grow at a constant rates during normal 24-hour period because their growth is affected by the sunlight. Suppose that the growth of a certain plant species in a controlled environment is given by the model. So they're giving us this, where h is the height of the plant in inches, t is the time of days with t equals 0, corresponding to the midnight of day 1. Determine the rate at which the plant is growing at 2.1 days. Okay, so rate at a specific time. That's calculus, that's a derivative. So that's the first thing we're going to do. We're going to find the derivative of this function. Now remember, you have two different terms, so do the derivative of each part. That's just a linear, so it's just the slope, 0.2, plus that 0.03 is a scalar, so leave it out in front. 0.03 is your scalar, and then this is what you're focusing on. So sine turns into cosine, inside stays the same, but then times the derivative of the inside. And then from there, remember, if you're ever plugging a number in, don't do anything simplification-wise with your derivative. Just immediately plug the number in, and obviously you'd be putting this into your calculator. And there you go, increasing 0.352 inches per day. And there you go. So please make sure you do your homework. Again, it can get a little complicated. Students get tripped up with this notation and not realizing that, oh, that's really cosine all squared, and they don't usually see that it's a chain rule problem. So yeah, make sure you're practicing these and email me if you have any questions.